So we did a cool little activity ahead of this about like some NFL quarterbacks. It's cool if you didn't get to do that activity because you weren't here today, but we found a regression line. Regression line is just like a line that kind of fits the data, excuse me. Like I was going to say model and data at the same time, so the data. So like last time we said it was like linear or like maybe nonlinear. Like the math behind it tries to find that. And then the residual is just like the actual value that really happened minus the predicted. So let's kind of dive in. So like I'm pretty sure even though you've probably never bought a vehicle before, you know that vehicles lose value as they get older, correct? You know? So like here's what they have. They have some data about some Ford F-150s about how many miles it has on the odometer. So they did a random sample of like 16 different Ford F-150 Super Crew 4x4s. Just want you to make sure they were comparing the same style of truck, right? It wasn't just different trucks. They were all F-150 Super Crew 4x4s. They were selected from those listed on autotrader.com. Here's what they looked at. How many miles does it have on it, right? Versus what's the asking price for what they're trying to sell it for? Are we cool with what they're doing, right? So first, can you see the data is going down, right? Isn't it a negative relationship? Would you believe that the more miles that a vehicle has on it, the less the price is going to be in that case? So usually in a typical scenario. So they put it all into an applet, did a crunch on it, and came up with this regression line right here. This is the line that fits the data best. There is a ton of math behind it that is kind of above our pay grade, right? We're going to let the technology do all of that crunching, and we're going to trust that this is it, right? So predict the price of a Ford F-150 that has been driven 100,000 miles. Where does 100,000 go in for? You can let the graph tell you, is miles an X value or a Y value? X. So let's grab our calculator, and let's put that bad boy in. It's just a lot of nasty little decimals here, but it's 38,257 minus 0.1629 times 100,000. Please make sure you have enough zeros. Should have 5 zeros with it. And let's see what this equation predicts. Came out really nice, right? You know, 21,976. They probably won't come out that perfect. Did you guys get that same number as I did, or did I punch it in wrong? Please double check me. Is that what we got? Cool. So boom, 21,976. But that doesn't mean that's what every one of those trucks is going to cost. That is just predicted based off that, right? So let's identify a couple of things. Which one of these, I'll just color them for you. I got an orange boy right here, and I got a green guy right here. Which one of those is the slope, orange or green? Been a while. We got a final coming up, though, but which one of those is the slope? The green one, because isn't he in front of X, right? It's kind of backwards from what we're used to. They got the y-intercept first. So is it a 0.169, or is it a negative 0.1? I said the wrong number, 0.1629. Positive or negative? It's negative, so it's negative 0.1629. Remember, X is not a part of the slope, so it's just that number. But they say, like, what does it mean, right? Well, first off, what's the negative mean? This thing's going down. What does X stand for again? How many miles driven? So, like, and Y is the price in dollars. So how do you feel about this guy? Is for every mile driven, the price goes down $0.1629. For every mile that you put on this truck, you basically decrease the price of it by like 17 cents, 16 cents or something. For every mile driven, the price goes down. How come I didn't put negative in front of this? What word in English means that it's negative? It's going down. So let's see if you and a neighbor can just talk about it. We'll get it together. Which one's the y-intercept, and what do you think it means? Just discuss that with a neighbor. We're down with the fact that it's this 38,257, right? But, like, what does it also mean? Like, what does that mean? The price of it, if it has been driven 0 miles, like a brand new one, right, should cost $38,257. So we can kind of put that. That's the value of the truck with 0 miles on it. 0 miles. And for those who have never bought a brand new vehicle, you will never buy a vehicle with 0 miles on it, because I used to clean those cars at Lewis Chrysler a long, long time ago when they were brand new. They all have some miles on it because they had to drive it off the truck. They had to get it to the factory. So they usually have, like, the minimum amount of miles I've ever seen on a vehicle is 11, you know, because it has to drive around a little bit. Like, they have to service it. They have to do this. So they put some miles on it. You will never get a vehicle with 0 miles on it. Does that kind of make sense? It moves around a little bit. But now let's use the regression line to predict the price of one of those trucks if it's been driven 300,000 miles. I know we're newbie drivers. What do you think about 300,000 miles? Is that a lot of miles? Or that's a lot. So I'll punch it in to the regression equation. What you can do is this, if you have a smart calculator like mine. You see there's an enter button, like my equals button. If I hit right above it, it says entry. I can get the previous entry right there, and I can just go back and change that 1 to a 3, you know, by doing a little bit of editing on it. Your calculators, you may be able to, like, copy and paste the same thing that you did before, or you could just type the whole thing in. But what does this model predict the price of a Ford truck in this thing to be if you've driven it 300,000 miles? Yeah, negative $10,613. We're way too smart to know that that makes no sense. Why does that make no sense? Yeah, if you were going to sell that truck, you know, like to somebody else, you would have to give them $10,600 for them to take the truck. There's no way, right? Do you think that a truck that has 300,000 miles still has actual value to it? Yes or no? It will. You might not sell it for much, you know. It might only be like, okay, I'll sell it to you for $4,000 or whatnot, you know. But it's like, it's not worth negative amount. Why? Can you tell me an E word, it's down below, right, of why that didn't fit the data? The data went from 0 to basically 160,000, and we just predicted it for 300,000. Why was it so weird? Because 300,000 is an extrapolation. The model, that data is too far off for this model, right? Just like Dak Prescott's salary, it's like, whoa, bro, 2024 was way after the data that we looked at. So that is an extrapolation, right? So, cool. Then let's go with the residual. Is that what's next? Okay, cool. The residual, if you just look right here, here's an actual price. This blue dot right there, the actual price of one of these trucks, it's been driven 70-some-odd thousand miles, actual price of $21,994. But the model predicted this green dot of $26,759. Can you see that this is the predicted and this is the actual? Is it above the line or below the line? Below. So when you do the residual, you subtract the actual minus the predicted, and you see it was off by negative $4,765. A residual is just how far off is the actual from the predicted in that one. So it's a little subtraction. And you can see way back at the top, I have a formula for you. We're going to use that formula a lot today. And you have to do it in this order. Actual value minus predicted. So it is okay to have negative answers. That means that you were just below, you know, compared to a positive one would be above. So let's rock where we were at next. There was nothing to do on that one. But please make sure that that value, when you use that extrapolation formula, is a predicted value. It's not a real value. It's just this is what we're going to predict based off some data. So then we'll go into the least squares regression line. So here is a table of like somebody's foot size of just 6 random high school seniors. They just picked 6 seniors. They said, dude, how big's your foot? They measured it in centimeters, which is kind of strange for us Americans, right? But they measured it in centimeters. And they also measured how tall they were, right? So are you cool that I went ahead and put that into the applet already, right? So you don't, it's just 2 quantitative variables, right? Foot and height. I will begin the analysis on it. And it's all over the place, spread out. But what does this ask us to do? It asks us to, like use technology to calculate the equation of the least squares regression line. So if I scroll down, let me minimize this a little bit, and find the least squares regression line, I got this bad boy right here. Cool? So I'll give us a chance to write that down. It is y hat equals 82 plus 3.308x. And you'll have plenty of those questions on your homework. Remember, we're using 2 quantitative variables. You just scroll down and click that button, and it'll find it for you. So this is the slope. Bing. This is the y-intercept. But those are just 6 random high school seniors. I know this old boy is getting kind of old, but he's still on TV. Do you know who Shaquille O'Neal is? He is a very, very tall human being because he is a former professional basketball player and a center at that point. He is really tall, right? He also has really big feet. Are you with me on that? You know, he's got really big feet. So they say, let's use that regression line right here to calculate his height. He's got 38 centimeter long foot, right? So isn't that the length of the foot in there as the x-axis right here? So let's put 38 in for x. I'll let you guys punch that in. This is going to predict Shaq's height in centimeters for us. And we got 200, let's just call it 208 centimeters. Does that sound all right? You know, it's like he's 208 centimeters tall. And I think every human being in the world would ask, how tall is that? So I'll go to Google and do it. How tall is 208 centimeters in feet and inches? What do you think? It's not 6'8", it's 6.8 feet, which is probably like 6'10". Are you with me on that? What do you think? How tall is Shaq? Do we know that? So, how tall is Shaq? He's 7'1", right? So it predicted him to be about like probably 6'10". He is 7'1". Was that accurate? Not really, right? They're off by like 3 or 4 inches in that case. So why was it not that accurate? Try to find an E word that helps. Why was that not that accurate? Would you believe Shaq is like an outlier in this scenario because he's so tall and his foot is so big? It's an extrapolation. There's nobody that's got a foot 38 centimeters big, right? That's just too far off the graph, right? So that's an extrapolation. And then here's that candy data from last time. You remember like the sugar versus the calories and all that stuff? So here's the table showing all that. A scatter plot is made below as well as the least squares regression line. Use this equation to predict any candy that's got 7 grams of sugar. So here's the question you got to ask yourself because homework might have you do it the other way. Where does the 70 go? In for X or in for Y? There might be some stuff where you got to put it in for Y, so you look to your graph. Isn't Y calories and X sugar? What is this 70? Calories or sugar? So 70 goes in for X. I'll let you punch that in. What did we get? 498 something or other, right? You know, so about 498 calories. Look at it. That's very, very much what the graph shows right here. Pretty stinking close to 500 calories, right? But remember, there was an outlier, right? There was an outlier in this one. Which candy do you remember was the outlier? Peanut M&Ms, this guy right here. So how does that outlier affect the line, right? So we're going to get rid of it, right? So this was peanut M&Ms. And here's some weird stuff, right? I need to ask you, where is that outlier in relation to the regression line? And there's a lot of places you could be, right? So first, talk to me about the most basic. Here's the line. Where's the outlier? Above it. Are you with me on that? But you also have to know, in all of the data, is it also centralized? Is it really, really left? Or is it really, really right? Where is that outlier? Even though it's above, is it more middle, left, or right? Yeah, so like it's in the middle above, right? So that's what we're going to do. The middle of the data, but above. And what happens is, this is weird, right? But the way you can think of it is, first of all, sorry for you video folks, you won't be able to see what I'm trying to do, but you treat this line like a teeter-totter. And here, are you down with the balance point? Is like right here, like teeter-totter can go like this, you know? The outlier is like a magnet towards that. So like, it's not going to affect the pivoting at all. Are you with me on that? Because isn't this dot in the middle, like really close to the pivot point, right? But it's also, it's like a magnet. It's going to suck it up, right? Isn't it going to make that go towards the outlier? It's going to do that. Just like if I put all our ages in a hat, isn't like my outlier age going to make it go more towards 44 than it does 14 in that case? It's dragging it towards the outlier in that situation. So would you believe that this line is a little too high? Are you with me on that? It's too high because that outlier sucked it up. So here's what it looks like without it, right? Here's what it looks like with or without it. So this is the original graph, and this is the new graph with no outlier. How did things change? Here's the regression equations that I did. So in the applet, what you have to do is go through all that data and just delete the one that was peanut M&Ms, right? You just delete it out. So what happened to the y-intercept? Here's the original. Here's the new. What happened to the y-intercept? It got smaller. By a lot or by a little? Not bad. It's off by 10-ish. You know what I mean? So it came down a little bit. Right? Came down a little. Went down a little. What happened to the slope? Let's talk about steepness of this guy. Here's the original guy. Did it change the steepness by a lot, a little, or like, you know, it kept it the same, you know? This has got a slope of 2.8. This has got a slope of 2.6, you know? What do you think? Very little, right? Very little change. Are you with me on that? But it actually got less steep, you know, 2.8, 2.6, you know, just a little bit, but nothing drastic, right, you know? So it's a little less steep, but not much. It's a little less steep, but not much. And I know that is the last problem on your worksheet, but that's still not enough to like see how outliers affect this. So I have another one that we're just going to look at, right? So, but are we cool with that? Is because the outlier was in the middle, it doesn't affect the tipping of the teeter-totter at all, right? And it sucked the line up a little bit. That's why the y-intercept was higher. And when you get rid of it, the y-intercept went lower because it's just going to say, okay, we're not going to be magnetized towards that outlier as much. But here's some data with a different outlier. So this is about the varieties of beans compared to protein. Here is almost all of the data right there, but you see that dude right there. There is an outlier in that. First, let's ask one question. Where is that point in relation to most of the dots? Centralized, to the left, or to the right? Way to the left, right? And where is it in relation to the regression line, above or below? So here's what happened. The data should be doing this. Are you with me? This is what the data should be doing if we get rid of that outlier. But magnet right here, boom! Would you believe that it totally said, holy cow, we are going to have to include this guy, and it totally changed the slope of that bad boy big time because the tipping point is towards the middle of the data, right? And it just says whammo. Can you see old regression line going down from left to right, new regression line? If we did it, if we got rid of all that other stuff, it's going, all that data is going up from left to right. So it is really, really weird. If they ask you some questions about how that got changed, let me help you if you're not understand, but the outliers are treated like a magnet on that scenario. It's going to take your regression line, treat it like a teeter-totter towards the center, and wherever that outlier is, it is going to attract that line to go that direction. So very strange stuff, man. Let's have a good day and do some homework.